is basically what we're looking at here today is instead of working with finding out where two lines intersect, which we've done before, when you solve the system of linear equations, you figure out, hey, those two run in there. There's one ordered pair that fits a solution for both equations. Or hey, there's no solution because the lines were parallel. Or hey, there was an infinite solution because it wound up being the exact same line. Well, guess what? You can do that with conics as well as a heart attack. So what happens here?
You're making my
face. I just totally backwards. I was going to say you're making my face hurt, but it's backwards. Sure, you want to point to that one. So, George. All right, whatever. Who?
Me and Joy went to the game. Give him a hard time. George. Like, I already do that.
Just next time you see Seb, walk up behind him like this.
Oh, yes. I don't even like that. Yeah.
That's bogus.
That's funny. You're just like, that's funny.
It's okay. I've known him for. I don't know.
A while.
Have I known him for 15 years now? I think I've known him about 15 years.
I thought you were going to say 50. I was like, you are not over 50.
So what can happen is we can actually find the intersection points of a hyperbola and an ellipse. We can find the intersection of a hyperbola and a circle. Parabola and a circle. We can find the intersection of a circle with an ellipse.
That's insane. Why is that?
All right, so this is if you look at that closely, if I put in enough of these, what does it look like?
Venn diagram.
No, well, almost. That's a Venn diagram on crack. It looks like a slinky. It's a slinky. It's a slinky. So he starts peeling it apart. So what we're going to do is this. We're going to take and find the intersection of two graphs, which means we're going to solve a system of equations that have squared terms in them. Sometimes in this case, if you think about it, x squared plus y squared equals 13, and y equals x plus 1. Those two graphs are, well, one of them is a circle, and the other one's a line. We're figuring out where does the secant line intersect with the circle. Secant line is the line that goes to this. So you want to secant destroy that circle. So what we're going to do is this.
You say find the intersection of the graph.
Yep. What you're doing is this is the same thing as solving a system of equations.
Me too.
But a couple extra steps. So in this case here, we're looking at solving the system of equations where one of them is a circle, the other one's a line. Now, just like we've done before, we have many different options to set these things up. It's up to you to decide whether or not you want to do linear combinations, substitutions, eliminations, any of those methods.
You give me options and I'm asking myself.
Well, in this case, there's really only one way to do it. Substitution. We know, in this case, since we already have y by itself, the easiest thing to do is take y and substitute here. So you get this. X squared plus the quantity x plus 1 squared is 13. Now, ladies and gentlemen, this is where you're going to screw up. Don't kill puppies. Please, please FOIL it out. You get x squared plus 2x plus 1. Bring the 13 over, and you get that. I substitute in.
What does don't kill puppies mean?
The original problem.
Combine like terms. And we're here. ladies and gentlemen? When we ask Ben, ask that's what he was sitting there. Okay? Solve for x. What's your first rule of factoring? What's your GCF here to get your zeros? 2. If I take out the 2, what do I get? Does this 2 have any bearing upon the problem whatsoever?
No.
Nope. Yeah, so you don't have. If it was a 2x, it would have something to do with it. That would have an extra term there to worry about. In this case, it's just constant. Doesn't matter. What times what's -6? You have to be able to get 1. Now you're going to hear a lot of the next following statement. Our terms, notice in parentheses, are x plus 2, or x plus 3, x minus 2. Our zeros then are -3 and 2. So x is going to equal -3 or 2, which means there's 2 sets of ordered pairs. It could go through the circle twice, or once, or it could not go through the circle if possible. So I know that the 2 values of x that are possible are going to be -3 and 2. This step right here, by writing out when you get your first set of zeros, whether they're x coordinates or y coordinates, is extremely important. Write down the set of ordered pairs with whatever value it is, whether it's an x or a y. That way you know to go back and substitute that in. Okay? So here we've got x values of -3 and 2. And which of these 2 parts now is going to be easier to substitute in to solve for y? All right, what's -3 plus 1? What's 2 plus 1? 3. So those are your system. That's your set of solutions. Your solution set. I knew I did it right eventually. That's where those 2 intersect. Now, graphing these things is completely inefficient. There's no reason to do it whatsoever.
Oh, thank God.
We're going to.
Yeah, the catch. There's always a catch.
Okay?
There's always a catch.
Not too terrible?
Yes.
Yeah, you guys love it.
So honest, right? It's like the order of pairs.
Yes, ma'am.
There's always a catch. There's always a catch.
There's a lot more to it. That was just the first example. I think we're only going to do this for a day. All right, next one.
You just put it in solve.
Come on, guys, really. Next one. X squared plus 4y squared minus 4 is 0. Next one is -2y squared plus x plus 2 is 0. Now, Haley, I know you're going to hate this spot because you have to make a decision. No. I'm not correcting that, that's all. The first one's an ellipse, the second one is parabola. Now, in this case here, we need to make a decision onto what variable to get by itself.
In the bottom.
So, you guys are saying, if you look at it, notice I've got squared terms. If I was going to get y squared, I'd have to get y by itself by moving a whole bunch of stuff around and then taking a square root. I don't want to take square roots to get something by itself because that's just a nightmare. But if I get x by itself, I can use that as a substitution later on. So let's get x by itself in that bottom equation. In doing so, all we have to do is move to the -2y squared and the +2. So I can say that the second equation is the following. X equals 2y squared minus 2. Everybody okay with that?
Yes.
So now, I can substitute this value of x here, and then I only have one variable to worry about, y. So it's going to be y squared and whatnot. but we can work through it without too much of a hassle. So in substituting this in, remember, you now have 2y squared minus 2 quantity squared plus 4y squared minus 4 is 0. What were you guys saying? Oh, can you do that? No. You can't take a square root because it's not junk squared. You can only take square root when you have junk squared. Each individual term is like that. You can't do that. You can't. What's that?
Isn't that junk squared? Because like it'd be that times itself.
But if I take the square root, what happens at 4y squared minus 4?
Wait, why is that number?
You can't do that. Okay? Foil this out. What's up?
Why did you square the 2y squared?
Guys, ladies and gentlemen, I can't hear. Why is it squared? Because it's x squared here. X is this, so I substitute in. Okay? Foil this out. I'm assuming, or actually I shouldn't assume this, but I'm hoping you remember something about exponent rules. When you multiply things together with their exponents, what do you do to the exponents? Very good. I was hoping you'd do that. So you get 4y to the 4th minus a 4y squared minus a 4y squared. So we have minus 8y squared plus 4 plus 4y squared minus 4 is 0. You got that nasty looking polynomial.
Wait, where did you get 8y squared?
2y, I did 2, I foiled the outside and the inside, so I get 2y squared times negative 2 plus 2y squared times negative 2. So I want 4y minus 4y squared minus 4y squared minus.
Oh.
I just combined the middle there. Yes, sir.
It's not that nasty.
No, I know. As you get through it, it starts to simplify itself out. So you wind up now with 4y to the 4th minus 4y squared is 0. Are we okay with that? Now what do? You cannot square, for the last time, you cannot square root. You cannot square root here. Okay? Take out the 4y squared.
Oh, it's kindergarten.
And now you have y squared minus 1. Now you have two terms. GCL.
I was thinking add 4y squared.
If you do that, you will eliminate terms. And you will eliminate possible zeros. We never have done that, so don't do that. Okay? You have two terms now to set equal to 0. Oops. Which means I have a 0 at 0. And I have a 0 at?
And
Add 1, take the square root, so it'll be plus minus 1. Okay? So that gives me 3 possible y values for the intersection of our ellipse and our parabola. Okay? You don't need to know what the shapes are, I just recognize it from the equations. Okay? So, what's that? Correct. So now I know that I have 3 ordered pairs. 0, 1, and negative 1 for my y's, and I got to figure out my x's. So I move back up top here, and I know that, excuse me, I had this equation already set up to solve for x. Everybody see that? Oh. Remember how you got x by itself? X was 2y squared minus 2. So we go through the process. What's 0 squared? What's 0 times 2? What's 0 minus 2? What's 1 squared? Excuse me. 1. What's 1 times 2? What's 2 minus 2? What's negative 1 squared? What's 1 times 2? What's 2 minus 2? Those are your 3 intersection points.
That's all you
Yeah, that's the system of equations here. Because basically what you have I'm not exactly sure which way it's stretched, but let's see, that'd be over 4, so a squared. So this is a stretched vertical. This is a stretched vertical ellipse that has a center at the origin, because there's no h and k. All right, and then the other one is a y squared parabola with a 1/2 p, I believe. So it's doing this. Somehow it's got to have, what's it at? 0, 0, -2. Maybe it's this. 0 and 1, and 0 and -1. So it's doing this. That's what that intersection probably looks like. Is it too legit? Is it too legit to quit?
Joy does not look bad.
I need to get a What was the joke on it?
You don't know, remember MC Hammer?
Can you explain the joke?
Too legit. I didn't know there was legit to quit. I thought MC Hammer.
What?
It was a good music. Trust me, it's not. Yes, sir. Try another one.
Off the top, at least.
If I'm not mistaken, this works out to become an ellipse and a hyperbola. Yes, ma'am?
Do you need to know what shape they are?
No. No, but if you start looking at it, you notice in the second one you've got x squared minus y squared, and if I say that equals 9,
Yeah.
that's going to be a hyperbola with a squared and b squared equaling 9. No, because it's minus. Okay, it's minus. Now, the top one, you'll notice how there's an x squared and an x, which means I can have to complete the square for that. And then there's just a y squared, so that's at 0. And then I'd have to divide everything then out by whatever it works out to be. So that one has to be an ellipse. I don't care what the graphs look like. All I'm saying is that I'm just emphasizing, hey, I can probably figure out what they are just by looking at them. Yes, ma'am? Good. I don't want to talk to you. Okay? So in this scenario here, you'll notice that you've got x squared, y squared, an x, and then the other equation you have an x squared and a y squared. Which one do you think you're going to get rid of? I'm going to get rid of the y squareds. Here's how this works. Remember how you did linear combinations before? This is a great example of using linear combination. And now I'm just going to add them together. Add them together to eliminate the y squareds. Oh. So what's x squared plus x squared? 2x squared. Good. What's y squared minus y squared? 0. Bring down the negative 16x. And 39 minus 9 is? And now you're at something that's factorable.
Can we allow for that where like you move the y squared and the negative y
Sure.
squared?
You would have gotten the same thing, because then you would substitute in for y squared, you would have got x squared minus 9. You would have gotten the exact same scenario. It would have worked.
That's what I started out with.
And that's fine. You can get there. Remember, guys, there's going to be multiple ways to go about it. It's the idea that if you pick up on one that's a little bit quicker than the other, you're fine. Okay? Yes. Yeah, I'm just letting everybody get caught up here. So, guys, when we get to this point here, you're right. You could have said that y squared is x squared minus 9 and done that here. You would have gotten the same set. If you did that, you would have had x squared plus x squared minus 9, and you got the same thing. Okay? So now your first rule of factoring is, which is? What times what's positive 15? Do you have to get negative 8? positives or negative. So that tells me my terms, parentheses, terms, x minus 5, x minus 3. Zeros, therefore, are 5 and 3. So now I go back up. Wait, holding on. But wait, there's more. It's slices and dices of Julian's fries.
Wait, so you could do all of Wait, and that is
What's wrong, Ed? No, say it.
So, are these not weird?
I don't know what you're talking about.
Might as well kill myself if you're down. I'm not done reading it.
All right. So now we have 5 and 3 for possible zeros.
Stop laughing.
Okay. So here's what happens. Right now, we don't have an equation that is set up to get y by itself. So what we have to do is use the one we're given. Right now we have y squared is x squared minus 9. Are we okay with that? So, excuse me, if
You should stay home a couple days. Next day.
what's 3 squared? 9. What's 9 minus 9? 0. What's the square root of 0? Okay. What's 5 squared? What's 25 minus 9?
16.
What's the square root of 16? Or? In this case here, this is one of those examples. When you have a y squared or an x squared, when you take the square root, remember, anytime you take a square root over the equal sign, it's going to be plus minus. So it is possible that you can get a duplicated value without knowing that it was a duplicated value here. Does that make sense? It's one of those weird things that can happen. Yes, ma'am?
I thought you couldn't bring the y over like that because it's a negative y squared and a negative 9, so wouldn't it just wind up being like x equals y squared minus 9?
And that's what I did.
Or plus 9, I think.
Whoa,
It's
no,
like if
no.
it's-
You add the y squared, you get x squared minus 9 is y squared.
Oh, okay.
And I just flipped it.
Oh, I just did it where like I had x on the one side and then y squared plus 9.
Oh,
It
you still have to you have to get y by itself. So.
just, yeah, but I mean, like if you were
Do
still
more work.
if you were still like putting like the 3 back in there, it would still work. But you just
And that for that example, yes, it's 0. But if you did the other one, it's just like you'll have 25 equals y squared minus y squared plus 9. So you're gonna move the 9 over and take the square root. See what I'm saying?
yeah.
I mean, it's not. You're not terribly
It just
wrong.
seemed easier because there were no negatives. But
I got it. Yeah. No, it's not a circle, and it's not a circle because that's going to be a subtraction. Yeah, this is an ellipse that I believe, I don't remember which way it's stretched, but it's an ellipse and a hyperbola. It could be. I got 5 of them for you, and if you give me a second, I'll put them on the board. Okay. Yeah. I don't. You might not have heard me. Mr. Rowe was asking me about that. I just finished up second hours. I will start yours maybe this evening. I don't think so tonight. But I'm planning on working on the bulk of. I had all of yours to finish, then I have 110 proof tests to look at. So, I know, right? So, It's a lot of fill in the blank, so that's not going to be too bad for those. But I'm going to get yours done first, so I'm going to try and get yours tests done tomorrow morning. And then I'll work on the geometry stuff the rest of the weekend. But yours, I'll make sure that yours are definitely done by Monday. Yeah, they'll be in. They'll be in. I don't know if I'll have. I have to get them done tomorrow because Sunday my wife and I are running the race, and then we're going to the parade. So I don't think we'll be doing. Yeah.
Hey, I'm running it too. I'm actually walking over it.
Yeah. If Anna was your if Anna was a true friend, she'd carry you. Ladies and gentlemen, you will get through a chunk of this. That's them.